Hello everyone and welcome to the class of Principles of Microeconomics Econ 111 Lecture 20 Cost Curves and Their Interrelation. So this lecture is also a continuation to the previous lecture, and in the last lecture we saw some of the cost variables such as the fixed cost, variable cost, total cost. Then we also found the averages of those costs and named them as average total cost, average variable cost, and average fixed cost. Then we also graphed them and saw their relationship. Now in this lecture, we are going to discuss the relationship between these graphs and the reasons for the specific curvature that these graphs gives us. So let us start with it. So the first curve that we want to discuss here is the marginal cost curve. We already know about the marginal cost curve, that the marginal cost rises as the amount of output produced increases. And this is related to the marginal productivity of labor. And we know about the marginal productivity of labor that let's say we take the output on the y-axis and the amount of labor on the x-axis, and when we increase the labor the output increases but with a diminishing rate, such that the marginal productivity of labor of each additional unit is declining. Now, when we convert that to the output per labor, when we convert that to the cost version, uh, the cost of each and every unit that we are producing, basically, if you invert this graph somehow, and we see this relationship of the cost, uh, the total cost, and the output, then the shape is upward sloping, and that is because it is the reverse image of the first graph, that of the productivity of labor. So this is the basic reason for the marginal cost to rise. Then this reflects basically the property of the diminishing marginal product, and we have discussed this property over here. You can now understand why the diminishing marginal product increases the marginal cost at each and every unit that we are producing. Then we need to understand the shape of the average total cost. The average total cost curve is U-shaped. Why is that so? Again, it has two reasons. One reason explains the downward slope of the average cost, and the second reason explains why it moves upwards after a certain quantity that we are producing. So what causes the shape, the slope to move downward, and then the second reason explains why it moves upward. What are these reasons? Let's look at them. At a very low level of output, that is when Q is low, the average total cost is high because the fixed cost is spread over only a few units. We know that the fixed cost divided by quantity is the average fixed cost. Now when we are producing a single unit, the total fixed cost is divided over this single unit, and the more and more we produce, the average fixed cost declines, initially very quickly and later on with small marginal increments, and this causes the average total cost to decline because average total cost is equal to average fixed cost plus average variable cost. So when average fixed cost is declining, it causes the average total cost to decline. Then the second reason, the average total cost declines as the output increases. We now understand this. When we increase the output, the average total cost declines, and the average total cost starts rising after a certain point. There will be a rise in this average total cost. Why? Because the variable cost is rising. Now the second part, this one, the average variable cost, when this start to rise, this cause the average total cost to increase, hence giving the average total cost a U shape. Then we have another relationship, that is the bottom of the U-shaped average total curve occurs at the quantity that minimizes average total cost. You see, when we have, let's say we have the average total cost graph, the U-shaped curve. This is cost and this is the quantity that we are producing. When we reach this point, the very bottom, this point actually has the minimum total cost. At this point, the average total cost is minimized. See, it is apparent we cannot minimize average total cost uh, beyond this point. So there is a point, let's say we start here with Q, average total cost is high. Then as we increase the quantity, we reach to a point where the average total cost is at minimum. And then again, if we increase further, the average total cost will rise. So it is only minimum at a certain quantity. And this quantity is called the efficient scale of the firm. At this point, it has the least cost, but yet this is not the point at which the firm will produce, and we will understand the reason for that, because it is not necessary that when we reach to the minimum of the average total cost, at that point firm are earning at its maximum. There are certain other reasons that can explain the profit at the point at which the firm should produce. So if the firm is producing at this quantity, we say that this is the efficient scale of the firm, and on any other quantity, there is no efficient scale for the firm. Then there is also a relationship between marginal cost and the average total cost. What is that relationship? Marginal cost will always cut the average total cost at its minimum. Let's read that. Whenever marginal cost is less than the average total cost, the average total cost is falling. Alright? And whenever the marginal cost is greater than the average total cost, the average total cost is rising. So we also need to understand that graphically, without graph, this concept will be a bit difficult. So let's say we have the cost over here again and the quantity over here. We have this typical average total cost, which we know that it has a U shape, whereas a marginal cost, which is continuously increasing. Now, what we want to explain here is that when quantity is, let's say, at this point where the average total cost is greater than the average variable sorry, the marginal cost, at this point, at these points, when the marginal cost is less than the average total cost, average will fall, average will move downward. Then we have another point, let's say call this Q, if we call this Q1 and call this Q2. At Q2, the marginal cost is equivalent to average total cost, and at this point the average total cost will be flat. Then after this, let's say we are at Q3. At Q3, the marginal cost is now greater than the average total cost. Therefore, the average total cost will move upward. So why is this so? Let's use an analogy, and that analogy, let's say the analogy of cricket. In cricket matches, if you see that the run rate, let's say that is our average total cost, the run rate. If the run rate is, let's say, 10 runs per over, and afterwards the batsmen, they are scoring at 6 runs per hour, and that is the marginal score, that is the score in each over, that is 6 runs per hour. The average run rate will decline, it will start declining. When the run rate is, let's say, 8, and the marginal run is also 8, then the run rate will continue to be at 8, and that is the position where the slope is 0. It does not change. And let's say if the run rate, if the marginal score is, let's say, 12, then the run rate, if that is at 8, then it will start increasing up to the point when it reaches 12. So this is the basic concept for the cost as well. When marginal cost is less than the average cost will fall. When marginal cost is equal to average cost will remain the same and the slope will be 0. And when marginal cost is greater than the average cost will try to catch up. So that is the basic idea. So the relationship between the marginal cost and the average total cost, again, that the marginal cost curve crosses the average total cost curve at the efficient scale, and the efficient scale, we know that is the minimum of the curve, and we have described it already, that the marginal cost will always cut the average total cost at its minimum. Efficient scale is the quantity that minimizes the average total cost. And it is now also time to examine the relationship that exists between these variables. Let us see all these things graphically. We have already made a graph with pen whenever necessary in order to explain that, so that it becomes easy. But now let's see that all of these concepts in a single graph. Here is the graph, and we have the quantity of output on the x-axis and the cost on the y-axis. Now, what will happen? This is our marginal cost curve, which we know that it is always increasing. And we have the average total cost, which you can see that it decreases initially, and then it starts to increase. And you also see the relationship that the marginal cost curve is cutting the average total cost at its minimum point, and that is the efficient point, efficient scale for this firm. So the efficient scale, that is, the firm can reduce the average total cost up to, you can say, 1 rupee or $1. Then we have the average variable cost. The shape of the average total cost and average variable cost are very identical, but notice that the average variable cost will always lie below the average total cost. It will always lie below the average total cost. How much is the difference between the two? The difference between the two, let's say this gap, or let me change the pointer, these differences These are equal to average fixed cost. When we add up the average fixed cost in the average variable cost, we will move up to the average total cost curve. So the difference between the average total cost and average variable cost is the average fixed cost. How we know that? We also know that through equation, that is the average total cost is equal to average fixed cost plus average variable cost and average total cost minus average variable cost equals to average fixed cost. So that is the relationship between these two variables. Then finally we have the average fixed cost which starts high but continuously decreases, and you see this gap um, and this gap, these will be identical. This gap and here this will be identical. Similarly, this gap and the gap between the two, these will be identical. Then there are three important properties of the cost curve, and we should explain these properties one by one. The first property is that marginal cost eventually rises with the quantity of output. The more and more we produce, the marginal cost will rise. Then we have the second property, that is the average total cost curve is U-shaped, and we now understand why is this true. And then the marginal cost curve crosses the average total cost curve at the minimum of the average total cost. So these summarizes the interrelationship between all the average curves and the marginal cost curves that we have studied. So you should remember these three properties. Now we want to make another distinction between cost, that is cost in the short run and cost in the long run. What is the difference between the two type of cost? We are talking about the same cost, the average total cost in the long run and the average total cost in the short run. And why are they different? So for many firms, the division of the total cost between fixed and variable cost depends on the time horizon being considered. So what is a short run? What is a short run? Is it 1 month? Is it 1 day? Is it 1 year? How much is a short run? In the short run, some costs are fixed. The basic distinction between the short run and the long run is that in the short run, there are certain costs that are fixed. For example, the rent of a property that we are paying. We have hired a place and we want to produce goods and services, but what if due to certain reasons we are not able to produce the goods and services, we are making losses and we have to shut down the firm, but in the short run we still have to pay the fixed cost, the rent for that place, we are still going to pay that. And in the long run, if still we are making losses and the factory is closed, what we can do is that we get rid of that place, and that becomes a variable cost. So the basic distinction between the short run and the long run is that in short run some of the costs are fixed, whereas in the long run all the costs are variable. So there is no concept of fixed cost in the long run. And because many costs are fixed in the short run but the variable in the long run, a firm's long run cost curve differ from its short run cost curve. It actually means that we can, in the short run, we cannot reduce the cost, whereas in the long run, we are able to reduce the cost further because all the cost becomes variable. And this distinction between the short run and the long run allows us to discuss the economies and diseconomies of scale. So economies of scale refer to the property whereby the long run average total cost fall as the quantity of output increases. When in the long run we increase the quantity, the total cost will fall. Diseconomies of scale, on the other hand, is that in the long run, when we increase the quantity, the total cost will rise. And then there are constant return to scale. That means that in the long run, the average total cost stays the same as the quantity of output increase. So no matter how much we increase the output, the cost will remain the same. So let us see these three properties with the help of a graph as well. Here is the graph which tells us the output and the average total cost. So in the short run, we know that the average total cost is a U shape, and we have graphed that. Then in the long run, in a slightly short run, that is mean when we are covering a little bit more duration, we can increase the medium size, we can increase the inputs, we can double up the inputs, so we can move on to a medium size factory, and when we increase the quantity, then the overall average total cost will be low. Then when we increase more and more inputs, when we add up more and more inputs, we become a large factory, and the average total cost again rises. So basically these are all short run costs, and by using the minimum points of these short run costs, we can identify the long run cost. So in the long run, the average total cost will touch the minimum of all these three curves, and you see initially it has the same U shape, but now the U shape is spread over the quantity, and we can see that initially we have economies of scale. The more and more output we want to produce, when we are increasing the output, the average total cost in the long run is declining. Then we have a second stage where we have constant return to scale, and the more and more we produce, the cost remains the same. Then finally we reach to a point where after which when we try to increase the uh, quantity of cars per day, the average total cost in the long run starts increasing, and that is where the diseconomies of scale starts. So what can we learn from this? What do we summarize from these points? The goal of firm is to maximize profit, which equals to total revenue minus total cost. And when we analyze a firm's behavior, it is important to include all the opportunity cost of production, and it means that we should consider the explicit cost as well as the implicit cost. Then some opportunity costs are explicit while other opportunity costs are implicit, and we should make a clear distinction between them and count them whenever we are calculating our profit. A firm's cost reflects its production process. A typical firm production functions get flatter as the quantity of input increases, displaying the property of diminishing marginal product. Now we understand what diminishing marginal product is. And then a firm total costs are divided between fixed cost, variable cost, and fixed costs do not change when the firm increases its output, whereas the variable cost changes when the firm increases its output, whereas the averages of these two also changes when the quantity is increased. Average total cost is the total cost divided by the quantity of output. Marginal cost is the amount by which the total cost would rise if the output were increased by 1 unit. And the marginal cost always rises with the quantity of output, and average cost first falls as the output increase and then it starts to rise. Then the average total cost curve is U-shaped. The marginal cost curve always crosses the average total cost curve at its minimum, and a firm cost often depends on the time horizon being considered. In short run, we usually have higher cost. In the long run, we usually have lower cost, but if we increase production, the cost can still increase, creating diseconomies of scale. And in particular, many costs are fixed in the short run, but all the costs are variable in the long run.